Hello, everybody, and welcome to Sparring Partners. Today, we're going to talk about AI RAN, and well, it's a very common topic, but we're going to have a special approach to it in terms of why is that we need it, how to do it. We're going to talk about the concrete way in which AI gets into the RAN, and this is quite important because everybody talks about it. But it's really important for the success of the whole effort to do it well. What does it take? What is that we're trying to solve? What is that AI can and cannot do? What we should expect next. And I am extremely pleased to have Karsten Gaenger today from NETSCOUT. He is the principal product line manager for the RAN, and has been at NETSCOUT for a while. He is going to give us a great overview and also in-depth view of how NETSCOUT is approaching this. So Karsten, it's a pleasure to talk to you again here.
Thank you, Monica, for the nice introduction.
So let's get started. To get people a context, for those that might not know you, what is that you do? Actually, even for those that you know, because you have a new role at NETSCOUT. What is that you have been doing at NETSCOUT and before, and what is that you focus on right now?
Yes, right now I'm overseeing the RAN products from NETSCOUT in the RAN product line management team, and I've been working in the product management space since more than a decade now at NETSCOUT, and previously I was working for Tektronix and Tektronix Communications as well, more than a decade, starting from a rather technical role in engineering, and I started my career in the industry, more than 20 years now, in the research domain, in the academic domain at the Fraunhofer Heinrich Hertz Institute here in Berlin, in where I have focused my research on robust video transmission in mobile ad hoc networks. I guess I'm in the industry for more than 20 years, and right now I'm pleased to oversee the RAN products for NETSCOUT, and there are some or it's a great time to be here, as the industry is changing with AI ML quite a bit, and we're going to talk about this here specifically and maybe a little bit broader as well, to share our thoughts to that.
And I've been working with NETSCOUT for a long time, and what I like about you and companies like you is that you try to always improve, make whatever network are out there better. And clearly AI is a great opportunity in taking you one step forward because it gives you more tools to improve network efficiency, performance, cost, whatever you look at. There is a lot to that can be improved. So let's get started and start sort of looking at from the sort of a little bit from the outside. Why do we need AI in the RAN? Clearly, there's always room for improvement, but why do we need AI? Could we do otherwise? So what kind of challenges and how are they solved at a sort of high level, and then we can go deeper.
Yes, so AI can play a comprehensive and large role in the future for us in the industry, which, I don't have a glass ball here in front of myself, but I'm quite bullish in that domain that it will improve our customers to be successful in the business. Because what we see as well since decades now, and this is increasingly speeding up, that network complexity and network layers are increasing. However, and I think this is not a secret, that the revenues in the industries are getting more challenges, and the teams, especially here in technology and RAN, are not growing in the same space or speed as the technology complexity is growing. So in order to keep up with that, automation and AI, ML is required to manage the complexity of the network, right? So the recent example is of course 5G, as it is the first time that 3GPP has released a new generation, which is not a greenfield network, which I love. It's, I think, the right approach, that operators didn't need to deploy a whole new network to have coverage and so on before commercial revenues can be put on top of that. But it's the close interworking with anchor sites from LTE for 5G non-standalone is the great thing to have focus areas, business areas, downtown areas, cities, which can have, based on the LTE network, 5G coverage already, until we are now going into the standalone domain, of course, to have more sophisticated use cases. However, here, right, this complexity in having basically two network generations on top of each other, they need to interwork with each other, is hard. So we see that with we have the 5G logo, but then the 5G carriers may not properly allocated. Carrier aggregation, dual connectivity are examples for that. And then the user experience might not be as expected. And herein, we see that RAN teams need more visibility as well as better tools to actually pinpoint the problems, predict even problems potentially, and propose solutions until, and we're going to talk about that later here, we are on the journey to level 5 automation, where we might have zero touch networks and full automated networks, which is the industry vision for quite a while. And we are in an accelerated journey towards this goal.
Yeah, and as you mentioned, it's future, because no matter what people tell you, it's really we're just starting right now. So whatever operators have in their network is very limited, and it's going to grow, but there is a growth pattern. And as we move to automation, and in order to have real automation of a network that is so complex, you do need AI, because otherwise it would become unmanageable. We didn't have the people, we wouldn't be able to hire so many people. It did not even exist. So
exactly.
So we need it. But if we think about, sort of, we look at take the long-term view, how do you see it going in terms of the adoption? It's going to be a long process, but what is that you see happening first in terms of what is that operators are going to do first, and what is the sort of the low-hanging fruits here?
Yeah, so this is, I think, as well, kind of a nice opportunity for us on all levels, that we don't have to kind of in a step function go from 0 to 100, right? So we can adapt automation and network level automation per, so that we can adopt machine learning modules in various focus areas first, and then grow from there to agentic AI to agents to large language models, which can help rather less technical people to as well have access to data sets and complex analytics.
So from a NETSCOUT point of view, what is your sort of proposed path for the operators you're helping?
Yeah. So what we are seeing is that, or as well as a learning from the past, that we have to manage the timing, right? So there's a risk associated to that topic that we don't want to be too quick and make wrong decisions, and we also, on the other hand, don't want to be the follower and be not successful. So I think the challenge is here to find the common ground. And we as NETSCOUT and also in the industry are learning every year, every month, every day what that means. And here in the past, what we have seen is from early adoptions of machine learning and getting outcomes out of that is that we need to focus on input data sets. So correlated data and AI normalized data where the correct correlation is embedded in the data and not removed in the data, that ML models and AI models in general can make sense out of that. If data sets are mixed together, which are uncorrelated, the most complex AI cannot make sense out of that because they are mathematically uncorrelated, right? And this is focused to have the right data sets to feed models to be efficient, but also to get the best outcome and the best return on invest on the early adaptations of automation and AI.
So, and that is, I think it's really a crucial part that sometimes people forget because, as you say, if the data is not good, it's not reliable, or it's not the data you need, then you're not going anywhere. You can have all the great model, but that's where you have hallucinations, is where you have, it's not because the hallucinations oftentimes are due to the fact that you don't have a good data to start with. So how do you make sure that an operator has the right data, especially when they work in a network that, as I said, it's more complex. So it's probably different vendors, and the vendors have data that come out in different formats, in different levels of granularity. How do you make sure that it all fits together?
Yes, this is especially area where NETSCOUT has concentrated on early on, as we as well saw that the previous data sets we used in the industry, if we just feed it blindly into models and AI modules, the outcome was not impressive. It was basically garbage in, garbage out domain. So this is why we have concentrated already years ago on defining AI-normalized data sets to feed dedicated modules and agents to fulfill tasks which are helping the RAN teams or the network teams in general, device teams, performance teams, optimization teams, planning teams, etc., to make their jobs better and more efficient. So here, one of the main drivers is that with AI and ML, we can address challenges and we can address tasks which were before either impossible to do or impossible to do at the scale which requires to do that. One example, or maybe a couple examples, is that addressing the challenges with single call analysis, and that you have state machines that need to analyze calls from the start to the end and monitor all the procedures which are happening, including the handovers, what has happened before a handover, what is happening after a handover, how is all of that impacting the service quality of the subscribers. And if you are isolating things with just performance counters or something like that, the correlation is gone and the outcome will be poor. So here, in the case of NETSCOUT, we are using a comprehensive view on the call from the start to the end, correlating the procedural level, the RF level, with the service level, so that that operators get a holistic view on the network performance based on real procedures, RF behavior, and from here the models can go ahead and pinpoint to the real issue of service issues, rather than just giving indications, but also pinpoint root causes or what's going on during the call, and maybe what are good neighbor relations in terms of service quality, what are good handover zones in terms of outcome, quality of service to users, to subscribers, latency, throughput, which really matters. So herein, we are focused on three silos where our customers here or the network behavior is key, which is capacity, which is mobility, and services. And for those three major silos where our user experience is dependent on, we have created AI-normalized datasets, which can which use agentic AI algorithms to provide outcomes to our customers. However, which is as well most important is, and we can talk about that with a little bit more detail on the whole industry, right? So NETSCOUT, of course, is not alone in that sphere, and other companies as well have ideas, and even they are layers of products which our customer uses on top of the domain of NETSCOUT. And here it is important to have different systems interwork with each other. This is as well a focus area which we think is important based on our customer feedback and also industry efforts, where we need to define common interfaces that AI agents, AI modules, and datasets can communicate properly together. And here we see the MCP protocol, MCP server and client, as a key functionality which our customers are asking for to latch different products, technologies together, that the whole industry can leverage each other's domains and get the most benefit out of data sets, out of modules, and to increase the scope.
Yes. So before we get into the specifics of what you do, could you just sort of give us a sense of what is special, or what's different about your approach? Because as I said, everybody's talking about AI RAN and all that. But I think we're starting to see a difference. Not everybody's doing the same thing. Obviously, only you want to differentiate, but you come from a different background, you have a different approach. What do you think it's special or different about what you do at NETSCOUT?
Yes, so I try to touch that point already a little bit, that we are focusing on data sets as well as on areas where we think which matters the most, which is capacity, which is mobility and services. And here it is key to generate data and AI modules which are network vendor independent, as NETSCOUT serves the largest operators in the world. Our solution is completely cloud native, from the data collection point of view until the applications on top of that. We serve small mining companies with very little 5G or LTE networks in the enterprise domain, up to the largest mobile networks in the world with more than 500 million subscribers. Even more subscribers than the whole US has citizens. And this is all one scalable cloud native system. And here, as said, it is most important to focus on the data sets which remain the sense in the data itself, so that the solutions do not work based on uncorrelated statistics, uncorrelated KPIs. We try to keep the causality in the data itself, that the intelligence on top still is able to make sense out of the causality of an issue together, as just handover KPIs, for example, or performance metrics, other KPIs, counters, very often do not hold this causality anymore inherently in the data. For example, handover KPIs can be perfectly green, and it seems that the network is working perfectly. However, after a handover in a cell which was indicated as very good, many subscribers face call drops or interference issues after the handover, and also the measurements associated to that were very good. So just looking in individual instances or procedures in the call without correlating them over the course of the call together will lead to an imperfect data view, and then the largest AI models on top of that will underperform.
Absolutely. And I think that you're pointing in an interesting part, because again, as network complexity grows, it's not just looking at one element or one part of the system. You need to look at the end-to-end, so to say, to understand, something might look good, but yet the user is not happy because something else happens that is not captured at the very local level. And so that's a big challenge. But then when you talk about having models, AI, ML, and Gen AI models, and then agentic, how much do you develop in-house, or how much you can use that it's already available, so that because you don't want to reinvent the wheel, but also you don't want to use a large language model that is designed for a completely different purpose. But then on the other hand, you have operators, as you say, you work with different operators, big and small, different parts, and each has different needs. So how do you avoid not reinventing the wheel, and at the same time be useful and to adapt to different needs of different operators?
Yeah, so NETSCOUT here follows a twofold approach. Absolutely. So we are not AI research company or something like that. We are applying AI in the mobile industry to for applications to make sense out of that. So we are using existing modules, existing models, as well as existing algorithms, and utilize that to the mobile data set, which makes sense out of what is ongoing in the network as good and much as possible. And out of that, we are creating insights for various teams. And here we need to differentiate where AI is being used in the industry. So NETSCOUT is playing a role here in service assurance, in optimization, in pinpointing issues, reducing mean time to repair of issues, having potentially predictive analytics as well as analytics which is self-healing and so forth, which is here our vision in the industry in general when we go to level 4 and 5 autonomous networks. However, as we speak of right now, the AI train has left the station in various domains, as well as on the file layer and the MAC layer. We see AI adoption similarly, which is here where NETSCOUT is not playing a large role, but this is on the network equipment side as well as on the Open RAN side, where we are trying to here define ecosystem where AI can play a role in a defined manner. But here in the domains of file layer or MAC layer for interference coordination, interference canceling, interference avoidance, for example, little AI tools, AI agents are playing a role, scheduler, and so forth. So this is what we already been seeing in products, and they will be rolled out more and more in the future. However, this is still kind of on the level of 2 or 3 in the automation level, and to take always the next step in terms of network automation levels, this is a huge sweep actually. But as said, we all want to reduce risk and want to step by step learn in this. And I'm listening to speeches, to keynotes at conferences and so on, and I always find it interesting. And I'm asking myself, where are we standing in the level of or in the journey of AI in our networks? If we look at the Kruger-Cunning model, are we still in the hype phase, or are we already in the zone of consolidation and realizing the reality, and then in the linear learning phase? And I don't know, but I guess we are still a little bit in the hype phase, leading or becoming slowly into realizing where AI is being useful, what can it do, what not, at this point in time. And this makes, I think, the journey so much interesting. Having said that, I have lately talked to a network consultant in the domain, and he was giving me some insights or thoughts, which I find as well interested. And this is in terms of Gen AI, which were companies, and he's looking into consultant from the business side, where companies now are realizing that they need to manage their data sets in terms of AI-generated data sets versus truth, the ground truth, so to say, and that this is not mixed up, and that AI data sets will not get polluted, or general data sets in a company are not getting polluted with AI-generated data sets from hallucinations and all the things we are still struggling with, that models are learning based on that, not on AI-generated data, to be in an outstanding loop here, so that we are keeping kind of AI-generated data and ground truth data carefully separated, that models are learning based on rather reality than on AI-generated data. So I found that interesting where this journey is going in. As I have indicated, Open RAN, this is as well a large domain here in our industry, right? Which we talk since more than a decade now, in that sense. And I have just recently here attended Open RAN workshop week here in Berlin, where this question was asked to the professional audience. It was a mix out of academic presenters as well as industry presenters, and they sticked their heads together and shared their point of view on automation, on AI, on Open RAN. And what is a time frame? How long will it take until we become to zero-touch networks? And the professionals here answered probably between 10 and 15 years, or some even longer, right? So this is kind of a judgment from the academic side as well as the industry side, probably an average point of view. How long will it take until we approach so-called autonomous network? Until then, if we, and some people said we will never reach it, right? I don't know. I'm not yet clear on that. But until now, and this is as well what we see in the private scope, I think by now we are all using AI agents or AI large language modules to help us with tasks, right? So right now and for the next decade, I believe AI will help us quite a bit to be more efficient in our daily tasks. Is it private tasks or is it industry-based or professional tasks? To be more efficient and get the more return on invest. And this can be time and outcome, or can literally be money and return on shares or on the investment. And here as well, NETSCOUT is helping to help the industry and our customers to be more successful in that domain. And especially here, I indicated that maybe 15 minutes ago or something like that, in some tasks, especially for carrier aggregation performance, right? So basically our capacity in the networks is built on more carriers and more bandwidth, bundling them together into a single burst transmission to customers in our cellular networks. And to have that interworking visibility of carriers and permutations of band combinations, how they are performing per device, per subscriber, per cell, is a multi-dimensional task, which requires handish single core analysis and look how the carriers are performing, because just KPIs cannot give the correlation into the game. And NETSCOUT, as I said, is looking always into the start of the call to the end of the call, what is happening in between, and making correlated sense out of the data, which is helping the customers to make sense out of behavior where in the past, radio engineers had to do single call analysis for 2 hours analyzing a call, but obviously this is not possible to do at scales for millions of cells, millions of calls. And here AI can play, and automation, a role to automatically analyze the call behaviors, make sense out of that, is providing a situation awareness for the RAN engineers, performance engineers, optimization engineers, and provides them a proper situation awareness. And from situation awareness, we can go into prediction, behavior of the network, and also to problem resolution. Propose it,
Yeah.
right?
And
Until we get the closed loop in 10, 15 years or whenever that will happen.
yeah, I am very relieved and happy that you try to resist the hype without discounting the opportunity. So it's a huge opportunity, but we have to be realistic in what we can achieve in the short term. And there is a fundamental uncertainty of what even we can achieve in the long term. I mean, people can say whatever, but nobody knows what happens in 15 years from now. It's kind of like 6G. We know it's coming, but how exactly is it going to pan out? Well, we'll see. Which is not to say that which is not to say to diminish the opportunity of AI, but you just have to be very realistic. And I think that increasingly what we hear, and not just in telecoms, and in fact, somewhat more in other fields where our adoption of AI is progressing, as started earlier, is that you do have tools as a customer. Well, even as a vendor, you need to develop new products, but you do not have the workforce, the people that work, even an NETSCOUT. Every vendor has this challenge of how you integrate AI in what you're doing already, because that's a challenge from your point of view. But if we look at the operators, it's the same thing, that they want to adopt AI, they're committed to it, but they have to do it in a organization which where they do not know about AI, in the sense that it's a new thing. Obviously they don't, like we don't as analysts either. I mean, nobody knows exactly what we're getting into. And so you need to build trust in the new technology. You need to understand how to use it, and so that is going to require time. Even if the model is perfect, which obviously they aren't because we're still learning, but how do you get it into, how do you integrate it in what you have already? So what I would like to ask you is that, so in your existing clients, how do you see integrating? Because they're used to your product, they're happy with it, and are you going to go and say, oh, you have to throw it all away and start again with the AI? I mean, eventually it's going to be AI native, but it's not going to be AI native today. So how do you bring AI gradually in, or do they need to change everything? How do you help them to transition? Which is obviously a difficult transition, no matter how good your product is. It's just hard for them from their organizational point of view.
Right. So from organizational point of view, this is manifold, at least twofold. There are two dimensions to that. One is technology, which I think your question is kind of focusing on, but one is as well change management in a larger company, right? They are risk associated to AI, and there are also adaptation issues of the human flavor into this, right? So this has to be carefully managed, and I think that AI can be a great opportunity for the humankind, as well as to the individuals, and we should focus on that rather on the risks or so, which need to be as well, of course, managed and having a look at. However, I see, and I try to make or bring that point across as well in the private life. If you might organize a birthday for your kids or something like that, right? You can ask a AI agent or LLM module. In fact, what can I do with a 9-year-old kid in Berlin for a birthday party? And actually, it will throw you out ideas, and you can use it as sparring partner and so on, right? And and I guess all of us have done it, right? And if not, I encourage you to do that, right? And all of a sudden you become into the domain of prompt engineering, right? How can I make my questions better to get useful answers out of that, right? And this is helping us as well here in the professional domain, in the same sense that we can focus on more interesting tasks and be more efficient in our professional jobs, rather to do those manual investigations and this and that, right? Where machines and AI can help us quite a bit already today. And here, NETSCOUT is focusing in securing investments into deployments. As I said, we are serving the largest networks in the world globally. We have customers from Australia, Asia, Europe, as well as Americas, as I said, and they are from very small customers to very large customers. And here we are currently working into AI data sources. I would categorize them, which is the AI sensor, which is a data collector and data processing engine, which is correlating data for the world of AI, as well as we will have AI adapter, which can be plugged into the existing cloud native processing chain, which our customers are using to grow into the AI world with AI adapter, which is generating AI correlated data for our AI products. And these are the agentic AI modules, which I have just referenced, but I'm also very proud to reiterate that our CEO, Anil Singhal, has announced at our large user conference, Engage, this year, that NETSCOUT will be releasing large language models for telcos as well. So based on the AI sensor and AI adapter, we will also have a product of large language model, which is a great benefit. It's basically another silo in the product suite here, where we are seeing AI products in a rather machine-to-machine sense, where they are processing data to pinpoint issues in the capacity services or mobility domain and provide insights to users, or even eventually make proposals in fixing them. But LLMs is a nice way that a whole company as organization becomes more efficient and has access to data which previously only expert users has data. And I personally feel that as well every time I'm providing a product presentation or even a product demo to bring across very complex data-driven data sources and analytics to the audience, right? And here, a large language model, dedicated telco model, can provide the RAN expert knowledge to everybody, right? So you can just answer or literally type in the prompt, how is my network here video conferencing service going on today, right? And then you just have one button switch if you are an expert user or a rather executive user type, and you will get from the model the analytics. The model will look into the right data sets, will correlate the data sets, analyze the data sets, and will provide you a already groomed answer without RAN expert knowledge, just the outcome in terms of latency, throughput, sales or services which have an issue today, which you should look at with graphs and prediction, and also with proposals, what actions are to be taken next. So this tool can be used in various departments, starting from call center agents, where customers are complaining in, and they can use it and type in just the customer IDs, right? And then they get out of many databases and many data sources a combined service level view on really what is the issue with a complaining customer. Or as well as RAN engineers can use it to to help them finding insights and getting directly to the issue and the root cause of things by using a prompt, rather in querying data sets with tools and looking at charts and so on. So the interpretation of the charts and the data sets is already done by the large language model, which is spitting out the real sense which they have or can look at.
So if I'm a NETSCOUT customer, I would get the AI sensor and the AI adapter to fit in to basically cleanse the data, make sure that everything fits for the LLM. And I mean, that seems like a very important, first step. And then you have an LLM that it's specifically targeting networks. Does that address the issue that many people have, that they say, well, you add AI in the RAN, you're going to have an explosion in terms of power consumption because you need so much processing? But then again, if you look at the LLM that you use to get information about kids' birthday parties, it just that model looks at the whole internet. But we don't have to do that in telecoms. It's a lot of data, much less than the whole world. So does that address the issue of are we using too much power that is, at the end of the day, it's not worth it because, well, you save money, you make it more efficient, but you spend so much in power that it's not worth it?
Yeah, right. So our customers do not need to build new data centers at large scale for this, right? So we are using pre-trained models already, which we are rolling out. However, we expect them to be trained in the customer networks as well, because actually every customer network is behaving differently. So this is also a dimension which our customers or the industry needs to keep in mind, that they are different settings, they are different environments in which each network is operating in, and the behavior is different. So the models will learn actually in the specific RAN environment to make specific outcomes to our customers. And I can reference here one AI product which is on the market since a few years now from NETSCOUT, which is our AI-based geolocation algorithm. And we are focused in geolocation to have the best geolocation in the industry since years now. We have a dedicated geolocation team. They are based, or it's a spin-off of the Berkeley University in California. Many PhDs are working on that topic. And herein, one of the outcomes here is AI-based geolocation algorithm. And this is actually not one algorithm, but it's a million or hundreds of thousands, depending on the size of the network, AI algorithm, because each individual cell in the network will have its own AI geolocation agent, and it will learn the physics in each cell in order to make the best geolocation outcome for the call. as we are geolocating in real time all the calls in the network all the time to make also spatial sense out of the performance of the network. Where is my performance good and bad? Where are coverage holes? Where is interference, call drops, etc. And for that, we need to rely on accurate geolocation data. And for that, because we are always network equipment vendor independent, we have our own geolocation algorithms geolocating all the calls in the network. And one of our latest flagship products here is an AI-based geolocation algorithm, which, as said, is learning basically the physics in each particular cell to predict based on various predictors in accurate geolocation long lat fix of a given subscriber, because the RF environment will behave always similarly at a street corner or something like that in my cell, and the AI algorithm will then say, oh, well, I have seen this RF environment before, and I know that those guys are at the street corner, so I will accurately geolocate them at the street corner to map the network performance measures and network behavior to exactly this area. And here we have very good results in terms of power consumption as well as in terms of network footprint. We have invested a lot into performance improvement, and I think at the end of the day, the models itself will be more efficient to apply in our networks than previous algorithms, because yes, the learning will consume power, but the learning in a network is, especially the pre-learning, is finished when it's in a steady state environment, and the models actually itself, by conducting actions, can be very efficient.
Absolutely. And yeah, and I think it's really important. And sometimes people forget that once you've learned it, you might want to improve on the learning, but you don't have to constantly do the learning. But that also sort of brings the issue of what is that needs to be centralized and what can or should be pushed to the edge. So clearly, if you have massive computational requirements, there's just so much you can move at the edge and not be too expensive. But if the power requirements are not that high, then the more you can push to the edge, the better off you are, especially if you are predicting in real time. You're closer to those. So how do you look at the centralized versus edge in terms of?
We are totally flexible in our deployment scenarios. Usually, the deployment will be in data centers, and distributed data sources will be aggregated and crunched together, and probably to have a more holistic view on the network that might be more successful, as we have seen in the early SON adaptions, that distributed SON is actually failing, because you have to consider the larger scope, or at least medium scope of things, what is ongoing, because they relate on each other. And if you leave that out, for example, the neighbors here of cells or something like that, if you just consider one cell at a time, that is obviously not leading to success. I mean, this is not new. This is well known what I'm saying here right now. This is why we have in the SON domain here rather centralized SON, which is deemed to be more successful in that sense. So yes, we will have centralized systems, but we will as well have distributed systems. One example was the mark and file layer, kind of AI agents running there, doing specific tasks in the cells, in the domain of here massive MIMO, beamforming, etc. Right? They don't need to be fed back to centralized systems. And here, also in the Open RAN world, we see that the industry is trying to define something like the SMO, so the real-time and non-real-time rig, where X apps and R apps are latched together. So this is also out there for quite a while. However, we don't see actually large deployments of Open RAN yet. Maybe this will change in the future. I don't know. I'm happy to hear that, and I'm always talking to customers about their roadmap about Open RAN and automation to that, so that we can lead with products and help them in that domain. But here it is especially important that things like colliding interests will be solved, because in the Open RAN here architecture, there can be different R apps performing AI agent tasks. For example, power consumption or energy saving can be one R app, and the other one is dedicated to your performance related topics or to interference related topics, but they can make changes to the network which are contradicting each other, right? So if you want to increase the performance in the network, you usually don't shut down carriers and cells, right? Which the energy saving one will do. So and this needs to be resolved at a centralized higher level to manage this. And this is still a topic which is currently being solved in an academic sense as well as industry product sense, that not singular AI tasks will actually interfere with each other. So this
Absolutely.
is one risk, right?
Yeah, and I think it's going to be crucial because, again, the complexity is an opportunity, but also you have to manage it. So now we have a few minutes left, so maybe you can go into something kind of more sort of deeper. You mentioned ML, AI, LLM agents. How do they? What is that they're useful for? Where is they use one or the other? And maybe give us some specific example of that.
Yeah, a little bit to wrap up here, maybe. So we basically here have talked about two major groups of AI, right? So one is in the automation way, embedded in the networks itself, as where NETSCOUT is playing a role here with their automation tool sets, the AI sensor, as well as the products in the domain of capacity, mobility, and services, where we can latch on AI tasks and products which has situation awareness, for example, and eventually make predictions in the network once we are becoming closer to the vision of zero-touch networks. And then there is a large other domain where the human interaction with AI and automation and data becomes a role, which are large language models or dedicated telco small language models, where we basically can utilize the artificial intelligence in favor of us, that we are all becoming a RAN expert all of a sudden, and can make sense of very complex data sets and correlations, which just a handful of RAN experts in a large operator could make sense out of. But this is kind of opening up this know-how to a larger scale of groups. This can be a set, even groups which are interacting to subscribers, to customers, ticket resolutions, but also in large operators, we have hundreds or even thousands of users of our tools in the networks. And of course, there are different levels of technology depths there, where we can make the whole teams more efficient by providing a dedicated large language model to provide them answers with their daily jobs, right? To make them all 1,000 engineers who are using tools like us can be more efficient in terms of time or in terms of outcome.
Yeah, absolutely. And, as you say, it's really important to keep in mind all the different aspects about AI, and we are learning in all of them. So, very final question. What's next? What are the highest priorities for NETSCOUT and for the industry to get us moving forward in a most productive and successful way?
Yeah, so I think we need to interoperability or look at interoperability that, as I said, there is a defined API, so to say, which is MCP, where AI or different AI agents, even from different companies, can talk to each other, where NETSCOUT is looking in to provide MCP servers, where other AI tools, maybe even from other companies, even from hyperscalers, look into AI, of course, as well. Here we see, unfortunately, the lack of domain knowledge. However, there's a lot of knowledge of AI and machine learning, and we all know the brands and the names here. However, the data source and domain knowledge is not always available. And here, the NETSCOUT can play a major role in providing that domain knowledge with MCP interfaces to other larger AI initiatives in any type of industry, more or less, where MCP is basically bringing the things together. There are other initiatives. I have mentioned Open RAN initiatives already, but there's also the AI RAN Alliance, which major industry players here are being part of as well. And here we need to see that when the industry is socializing, defining interfaces, and how things to approach that, this can at the end bring a larger benefit to all of us, where domain knowledge, data experience is then connected with other experience on a larger scale, maybe to bring a larger return on invest on the AI sweep as well. And of course, we have not yet even talked about 6G, where AI will play a standardized role in that domain. Here I see not only the network layer, but also the data layer. And I just have read a press announcement from the Heinrich Hertz Institute, where I was, as I said, a couple decades ago as well, where they have socialized with Ericsson and Nokia to define a standardization for 6G for video codecs. So here, source coding of the video and network coding for the network transmission at the end of the day becomes jointly together, that source and network coding for videos for streaming becomes one, and that the video codec becomes network aware, and the other way around, to have more efficient ways in playing multiple domains together with each other. And this is a good example where we need to go that domains come together, defining interfaces, and define a joint data set or joint product set to make a 6G maybe a success. However, of course, if you ask operators about 6G or something like that, they usually say, well, we don't have a proper 5G SA network yet, so leave us alone with the next generation. We want to leverage the first one. or the current one first before we make the second huge investment into 6G. And as we have just said, I mean, AI and automation and increasing efficiency is also applicable to 5G as well, even to LTE, right? So I see this as the next steps to focus on AI agents in the various domains, then to grow into a more holistic way, which might be defined with 6G, and that will be the path into the future.
Absolutely. And Karsten, thank you so much. I really enjoy our talk because you've been providing us with a sort of very sort of hands-on perspective on AI. Clearly, there's a lot of work to do. There's like huge opportunities, but we really need to keep in mind all the moving parts that go into it to make it successful. So again, thank you so much, and for sharing with us all what you're doing and the great job you're doing at NETSCOUT.
Thank you very much, Monica. It was a pleasure to talk to you again.
And thank you all for listening to us. It was, I hope you found it as interesting as I did. And if you have any questions, let us know and we'll get back to you. Thank you.